Right, so we've got this curve C with the equation here, so quadratic, so we know it's a smiley face, right? And it says then in part A, the point P has coordinates 6 minus 5 and lies on C. Find the equation of the tangent to C at the point P. So, if I got the part of the curve there, maybe, okay, at this particular point P, okay, the tangent, remember the tangent is a straight line that just touches the point P here, okay, at that particular point, yes, so the point is 6 minus 5. Now, of course, the tangent, okay, a straight line, and we want the equation of it, but the tangent will have the same gradient as the curve, yeah, okay, because it's got the same slope as the curve at that particular point. That's the definition of a tangent. So what I'm going to do is I'm going to work out the gradient by doing the gradient function, dy dx. So I differentiate this, bring the 2 down, so I get 2x, and then minus 9x becomes minus 9, okay, and the 13 just disappears. So at that particular point, when x is equal to 6, dy by dx will equal to 2 times 6 minus 9. Alright, and then you get 3. So the gradient of the tangent then will also be 3. Okay, because that's the gradient of the curve, which is the gradient of that tangent then. So we've got a point, and we've also got the gradient. So then you can get your equation. Okay, so the equation of the tangent, okay, will you get by using, of course, the equation that we learned, y minus y1 equals m, x minus x1. So y minus, now the point is that, so in this case the y coordinate is minus 5, so go minus 5 in there, gradient then 3 and x value is 6, so you know then that becomes plus, doesn't it, because 2 minuses make a plus. 3x minus 18 when you multiply it there, and then if we just get it all onto one side, 3x minus y minus 23 equals 0. Okay, that would be the representation there. Or you could just simply say y equals 3x minus 23. Okay, whichever, it doesn't matter. Part B then, it says the point Q lies on the curve such that the gradient of the normal to C at Q is 1/7. Find the x coordinate of Q. So, if I sort of do another little sketch here, and I'll consider point Q, okay, now it's saying that the gradient of the normal, okay, the gradient of the normal, and remember the normal is perpendicular to the tangent. So if I draw the tangent in first, maybe I'll draw that with a broken line. That's my tangent. The normal, of course, is at right angles to it, yeah? Okay. So I know it says that the gradient of this normal is what we got at 1/7, yeah? So we know the gradient is there. So if I got the gradient of the normal, I can get the gradient of the tangent, can't I? Using m1, m2 equals minus 1, because they're perpendicular. So 1/7 there, m2 is minus 1, so m2 will be minus 1 over 1/7. And remember, fraction on the bottom, you flip the bottom number up, take it up, so it becomes then 7 on the top when you take that up, over 1, so it'll be minus, of course, then 7. So the gradient of the tangent will equal to minus 7. Now they want to know what the x coordinate is here. What is that x value? Okay, they're not interested in the y, it doesn't matter. Okay, they want the x coordinate. But if you think about it, okay, if the gradient of the tangent is minus 7, that means the gradient function up here will also equal to minus 7, i.e. dy dx is equal to minus 7. So we'll have 2x minus 9, which is the gradient function, equals to minus 7. So then to get the x value, we just solve the equation. Take the minus 9 over, becomes plus 9. Work that out there, you get 2. And then, of course, your x value then has got to be 2 divided by 2, which is just 1.